Okay. The volume, if you're watching at home, may stink, but I don't know what to tell you. We'll do the best we can because it's probably using the other speaker. So right here, I am going to type in, here's my 84. So if I want to type in the integral, I got to go math 9. So I'm putting in the integral from 3, go up to 5, and then I'm coming down. Now, I'm going to have to cube a cosine. Well, when I hit cosine, it's going to give me parentheses, and I won't be able to put that cube in there. So what I have to do is, in parentheses, wrap that cosine and cube the outside of it. So first I'm going to go ahead and put e to the 2x. So I don't use the letter e, by the way. If you have an Inspire, don't use the letter e, use the e function. So on this, I'm using the 84. So the e function is right over the natural log. So second e, go ahead and put my 2x in there. Then I'm going to come down, and you can put times if you want, but I'm going to add an extra parentheses. Now, when I hit cosine, it puts an extra parentheses. So I'm going to have to put the 4x, close the parentheses for the 4x, close the parentheses around the cosine, and then raise it to the 3rd power. Are y'all seeing that? So that's the only way that you're going to get, and that is not the right answer because I am in my degrees. I need to be in radians. So I'm going to go back and redo that, and I get 3,498.746. And we always round to 3 decimals. So that's how I would have entered it. You have to know the limitations of your calculator, okay? And that's a safe bet even on the Inspire to type it in like this, except when you start your integral on the Inspire, it won't have a parentheses in there. Yes?
Is there a possibility to let the 3 like a cosine?
No, not on an 84. And if you find out how to do that, let me know because I don't know how. So literally, you have to cube the entire thing. I would love for you to be able to put it in there. I don't know how that works on an 84. I don't think it does. But if it does, I don't know how. So I would be happy to be enlightened, but I'm pretty sure it doesn't. Because this is a crap calculator, and I don't care about it really too much.
I just lost 3 years.
Okay, so here we go. Now I'm going to the calculate part. On the Inspire, I'm going to go, you can do it a couple different ways. I'm going to go to my little integration button, which is right there. Sorry, which is right there, but you can hit the calculus, whatever. Get that on your screen. 3, 2, 5, and then I'm going to come down. Notice there aren't built-in parentheses there. So you just got to make sure that all of your stuff is right in there. Now, the second I hit the e function, when I hit e, again, don't use the letter e, but use the e function. I'm going to raise that to the 2x, and I'm going to come down or to the right, and I'm going to go times. And the second times you see it puts a parentheses in there. Okay? So when I do my cosine, if you want to be safe, go ahead and put another parentheses in there. And then type in cosine, which is the trig, cosine of 4x. And then you go outside, not the 4x, but outside the cosine's parentheses and raise that to the 3rd power. All right, and then de-exit. Make sure that I'm in degrees right here. So I'm going to go up there and click, change it to radians. And when I hit enter, 3498.746. Now, you might, right here. Can you do this?
No.
I don't know that you can.
It says that you're missing a parentheses, but I don't know like where you would be missing.
Hold on. Let me just check this. No, see, it won't let me do it even on that. So even though it looks good there, right there, cosine cubed, it's not going to work for you. So who says I'm missing a parentheses?
No, like the calculator just said that you're missing one when you had it.
On the 3?
Yeah, when you have the cosine outside of the 3, or the 3 on the top.
I honestly didn't even read it. Hold on.
But I don't know where
Cubed.
it would go.
Missing a parentheses. Yeah, I don't know where it would go either because I'm not missing one. I think it's just freaking out a little bit. And again, I don't know why. So whether you have an Inspire or not, but look, guys, it's really easy. This is what people do all the time. They come in here and they're up there at the 2x, right? And then they come down, they go times, and then they do this. They go trig, cosine, they put the 4x in there, they come to the outside, and then they try to cube it. And what they end up cubing is not the cosine, but the what? The 4x. Or they make the mistake, which you actually cannot do this on the Inspire. Well, no, yeah, I can't even do that here. I can't put it right after that. But if I was able to put it right after that 4x, I would be cubing the e to the 2x as well, wouldn't I? So the bottom line is you have to make sure your parentheses are in a good place. Now, I don't have the parentheses in there now. So if I go to the beginning of cosine and hit left parentheses, it usually kind of guesses where you want them. And you can see it guessed correctly here and put it at the end. So I'm going to go to the end of that, cube it to get the right value. And listen, practice will make better. You using your calculator, do not hesitate. I know people are like, oh, I know how to use my calculator. Bull. I give these questions all the time on the test, and half the class will miss them. The more practice you can get using your calculator, the better you will be. And I will say this too, annoyingly, this is one of the downsides and one of the upsides of the 84 is every now and then on the Inspire, if you don't put times in there, you have an issue. So I kind of got in the habit of throwing times in every time I'm dealing with a cosine. Okay, or if you have it in parentheses, you're probably fine. But sometimes, for whatever reason, and I haven't bothered to investigate it, it just needs a times in there. So a lot of times you'll see me go function times a cosine, function times a sine, where you think it might not matter, and it probably shouldn't in regular PEMDAS, but this calculator, for whatever reason, may need that. And again, there might be a really good explanation. I just haven't, it's not worth it to me. I just put it kind of. I can't wait till we get to integration. And you're going, hold on a second, Mr. Hurry. Like my wheel's still spinning. Wait, one more second. Well, hold on. Yeah.
How do you get Inspire to like show you more decimal places?
Well, okay, yeah, you got to go to your settings. So you on yours looks new. If you just hit menu, if you go up to the little battery. Let me see. Yeah, if you go up there and click on the battery on the top right, you see how you get to see document settings? Are you there?
Yes.
And then you go to document settings. And what does yours say at the very top for display digits?
Wait, which button is it?
Go click. Oh, no. Go on your, well, you can probably do it here too. Go to settings, document settings. So you're floating 6 and on really big numbers. You're not going to see far enough in. So what I like to have it on is like hidden fixed. You want to fix 3 and hold around it 3.
Okay.
So now when you go to calculate, well, type something in there. 2, 3, 5, 6. You'll see all this.
Thank you.
Yep.
So on that 8, so I don't have a United sign up. If I were like going for the integration, like would I be allowed to have like a CI 84 and sign on the 8?
You're allowed to have, did you say, are you allowed to bring both? Sure.
Is that
Yeah, and I have 10, and I usually bring them to the room wherever y'all are testing, assuming you're testing in the building. When you are testing over at Sanford or whatever, I can't do that. But I think y'all are still testing here, probably up on the foreign language link, wherever you are. I'll have an extra 10, but there are 38 of you, and half of you probably don't have them. So there's probably enough for those who might want them. Actually, I have 2 of these. Maybe I have 3 of these that are mine that I've loaned out to people over years. But yeah, you can probably get one. Just a matter of making sure it has the right settings, the right decimals. I usually try to get all those set up, and then if you need one, or if one of you guys calculator goes back, I mean your battery is dead, or my daughter had one whose battery would just die randomly. So we kept, I think I went through 3 with her. She just treated it badly. But anyway, we'll get you in a good place. But yes, you're allowed to have 2 calculators in your possession. One might be a scientific, one might be graphing. You could have two different graphings, but you have that option. And as far as it working slowly, there's more than one way to skin a cat, basically. And sometimes AP is trying to get you to notice something like, oh, the derivative of the integral was the first fundamental theorem. The second fundamental theorem. I don't need to do all that work. I could simplify it, plug the x in, and just use f of x. Graphs very quickly. But if you type in the derivative of the integral of the calculator has to think through all of those processes. So and Inspire has a great brain and it thinks quickly. And 84 is literally like, okay, let me do the integral first. Let me do the derivative. And it could take 20 minutes to crunch the numbers. But AP isn't wanting you to do that. But sometimes the nice thing about the Inspire is when you don't notice that, it still gets it done quickly. Yeah. Okay. I love that. Yeah. I will say this, guys. If you're going to use an Inspire, you need to start knowing it now. You don't need to wait till May and go, look, I got my Inspire. It's like, if I'm going to go to Spain, I probably don't want to start learning Spanish on the plane. It's just not going to get me very far. I might want to do a little bit ahead of time. So my advice to you is start learning it now so you don't run into issues like not knowing how to enter something in the calculator on game day. Yes?
So like, if I want to do this, present those graphs,
It's up to you. It's your test. So if it were me and I didn't have one at this point, I'd probably just make sure I knew my 84 because it's not that big of a deal. It rarely is that big of a deal. It's just sometimes you hit a spot and you're like, uh-oh, this is taking forever. My oldest had an 84 because that's what they needed at her school. She didn't go here, but my others had Inspires. Their teachers didn't know. She went to this private school, my oldest, and they didn't know what Inspires were. The teachers didn't know how to use them. But I'm the only one, and Helmers are the only ones that use the Inspires. The other algebra teachers didn't want to learn it, so they ordered classroom sets of 84s. I don't know why they did that, but most schools use Inspires because it's just better. Anybody else have a question about this right here? Yes, no? Yep. Do what now?
For f of x, you do like when x is equal to 11. Number 1.
Oh, yes. So you're asking about this. So for the f of x is the integral from 2, not 0, from 2 to 11. So I'm starting here at 2, and I want to know what is the area from 2 to 11. Well, when I look at this would be my thinking. From 2 to 11, I want this area here. I want that area and that area, but I realize it's going to cancel because they're opposites. I want this area here. I want that semicircles area. And then I want that area there. And then also that. So right here, and also that actually cancels with that. If I notice that, that's a nice thing, right? That's a negative half. That's a positive half. So really all I have is 1, 2, 3, 4, 5, 6 plus whatever this is. And this is half, 1/2 of a pi where the radius is 2 squared. So 2 pi. So that's that area. And if you didn't see stuff canceling, well, this is 1/2 times height is 1 times another half. That's a 1/4. That's a negative 1/4. That's a 1/2. That's a negative 1/2. Eventually, most of that stuff cancels. You with me? Now, even though this quiz didn't have it, the quiz tonight, the second quiz in there, is it in your book?
Yeah.
That quiz, hopefully, it's been a while since I've looked at it. That quiz, do I have the key? Yes. But that quiz, I think, if I remember correctly, has a little bit, some different kinds of questions, has some approximation, has some more calculator integrals, has some fundamental theorem. Actually, it still didn't ask stuff. Guys, make sure you're knowing what to do when I ask you questions like, hey, where does big F have an inflection point? Well, if big F, when does normally big F have any function have an inflection point?
When the second derivative.
When the second derivative is 0 DNE and changes signs, right? Changes concavity from positive to negative or negative to positive. So you could just say changes signs. Well, if big F, if the second derivative of big F is the first derivative of F, right? Based on how we're looking at these things, then I'm looking where the slopes are 0 or DNE. Where do slopes not exist? Corners, cuffs, endpoints, vertical asymptotes, non-continuous locations. So as long as the slope was 0 DNE and switch signs there, then that on the F function, the slopes on the F function would be like the second derivative of the big function F. Those connections you have to make, whether I'm talking about maxes and mins, increasing, all of those things I've been talking about on these worksheets. If you're like, yeah, I stink at that. Well, like there was a homework problem I did not give you last night, but there's a whole homework page of practice problems. Go back and look at it. The key's right here. All right. So even though it wasn't assigned, because I wanted you to do the quiz, if you go back, there's quiz number 1. There's a homework practice sheet. Go do that and get some practice on it and see if you're good. All right. All right. So I want to jump to this. I call it AP Module 3 because I'm borrowing it from this guy. He calls himself the Master Math Mentor. Yeah. This guy actually really helped me. So I still give him an ode to no, but I've always wondered why do doctors get called Dr. Hurry? I've got a master's degree. Why don't we get called Master? You know? Anyway, even if I had a doctor, I wouldn't want people calling me doctor. I don't know. It's like, it just, to me, it's like, I'm a person. Call me by my name. I don't want to just always walk. And I'm not, if your parents are doctors, great, especially if they're medical doctors. But like, there are people I know that get like their doctor, and they're like, I can call Dr. Barnes just Dr. Barnes, but like, I love that Lana Johnson. You know, Doctor, you call him Dr. Johnson or what'd you call him? Y'all did call him Doctor? He goes, Mister. He's told me, dude, call me Lana. Don't call me Dr. John. But so many of the past principals we've had, assistant principals, second they get their doctorate, they're like, it's doctor. I'm like, oh my goodness, 10 years older than you. You know, it's just like, give me a break. Like I'm not going to, but whatever. It's just personal preference. If you have a parent that's a doctor and they're called doctor, awesome. They have earned that. But again, did they call me Bachelor Hurry when I had my bachelor's degree? Master Hurry?
Can I call you Coach? That's what I used to call you.
I thought Mr.
Yeah, I've had people call me that, but again, yeah. I actually was a coach for 1 year. I coached JV baseball. It was awesome. I loved it, but it was the year I was engaged to my wife, and I never saw her. Like I was teaching these tough classes, and then I would run out of here at 3. We didn't have a baseball field here at the time. I'd go to West Home, and I would get there at 4. We'd have practice till 6:30 or 7. I would get home, and I would do my work till midnight. And that's if we didn't have a doubleheader. If we had a doubleheader, I'd be working till 2. I was like, I can't keep doing this. But it was great. I absolutely loved it. But yeah, it's just if you teach, there are a couple guys that teach like Coach Donaldson. Dude, I don't know how he does. He must only sleep like 3 hours a night, 4 hours. I don't know. But that guy needs some help. I mean, he does way too much. They need to double his salary or get him some help. Because he's doing the job that 4 people did last year. And he teaches. Oh yeah. Don't get me started. Well, what my fear is that he is and go somewhere else. That's my fear. I hope he doesn't, because I love him here and I love what he does here. But twice. Yeah, he's on the wall.
Wait, where is he? He's somewhere up there.
No, I love him. He's overworked if you ask me, but whatever. Here we go, guys. AP Module 3. So I want you to think. These are just some random questions. See if you can get here. I'm probably on 123 or somewhere in that neighborhood for you guys. So right here, what if H stands for? So you're reading a word problem, and they say H of T, blah, 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 and it's the rate of change of the height of a pile of sand. So it's the rate at which the height is changing. And that they're calling that H. Now you may go, why don't I call that DHDT? Excellent question. They could have, but they didn't. And like if I didn't give it a name and I said, hey, what is, if you were reading the problem, the rate at which the height changes, you probably would call that DHDT, wouldn't you? I would have, but they didn't. They chose H. So you have to burn in your brain, okay, H really means the derivative. They're just naming it a different letter. And that might be bothersome, but get used to it, okay? All right, and then it says, then what would that represent? Well, you know that when you integrate a rate, you get a what? Change in the amount that that rate is referring to. So what is it referring to? If H is the rate at which it's changing, then the amount would be that change in the height, right? Are y'all seeing that? Because the amount was like height per second, or no, feet per hour. So this is going to give me an amount in feet. That what? From what to what? What does 0 mean? The time. So from the time it started till 5 hours later. AP loves asking you to write an integral or give you an integral and say, express in your words what this means, use correct units. Please do not go, that's the integral of H from 0 to 5. They can read the math expression. They want to know in whatever real life problem, whatever context we're talking about, what does that mean? And you would need to say, okay, based on what I'm seeing, this would be the change in the height, change in height, right? From time 0 to times 5. Now, here's why you don't want to say over a 5-hour period. I see people all the time. It's the change in height over a 5-hour period. Well, 1 to 6 would be a 5-hour period. 10 to 15 would be a 5-hour period. They want to know what 5-hour period. Now, here you could say first 5 hours because you did start with 0. But be really careful. The safest thing to say is just say it's the change in the height in feet, using correct units, in feet, from time equals 0 to time equals 5 hours. And if you get in the habit of saying that from t equals 0 to t equals 5 hours, but you can't forget the units. If you say it without the units, you get half your credit for that problem. What about V? This V is velocity. Okay, moving along an x-axis. Now, what is velocity? Velocity is a rate at which I am changing distance. Right? It's a rate of change of position, a rate of change of distance, whatever, depending on positivity and negativity. It's measured in feet per second. So what does the integral of velocity represent? Right. It's the what? Change in my position. Don't do this. Well, like, oh, it's the, like I have people all the time that go, well, if I integrate a rate, I get an amount. Don't say it's the amount of velocity. Don't say that. You know that you take a derivative of position to get velocity. You integrate a velocity, you get the change in the position, right? Not the distance, because could I change position by going positive, negative, and be right back where I started, right? Or I could go positive, 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 and end up over here. So unless it was absolute value of V, absolute value of V would be the total distance. We talked about that yesterday. But just a V represents the change in my position. So how do I word this? The change in the position of the particle in feet from what? T equal 3 to T equal 10 seconds, right? Now, that's the easiest way to say it. And you get your points. How about this? If V is the velocity of a particle moving along the x-axis at time t, and the position function is given by x of t, and you happen to know that at the position is located at 5 when the time is 2. What's another way of saying the position is 5 when the time is 2? What's a way of saying that with math? That x of 2 is 5. Right here, write an integral expression that represents the position at time 10. Okay, so x of 10 is what I want, right? What do I got to do to find my position? I got to know where what? Where I begin. Well, all I know is that at time 2, I'm located at 5. So couldn't I say, okay, if I want to know where I am at 10, I'm going to start at time 2, which happens to be 5, and do what? Figure out how much my position changed and add it to it. How do I find a change in position? I integrate velocity. Now, what A and B do you think I ought to use? The ones I have. So if I know that I'm starting at 2, start at 2. If I'm ending at 10, start at 10. Why don't I start at 0? I don't know anything about 0. If I knew about 0, I would use 0. That kind of makes more sense, right? If I'm starting at time 0, how much did I change? But I just didn't know 0. I knew at 2. What is this? First fundamental theorem. It may not look like it because I've subtracted that, but isn't the integral of v the change in x? Change in position, x10, final minus x2. I just moved that negative x2 over and made a positive x2. Right here, write an integral expression that gives the total, distance. What is distance? Absolute value. Isn't it possible going from here to here that I went back and forth and back and forth and back and forth? I don't know what velocity is doing. I don't know whether velocity is positive or negative. I could have been zigzagging all over the place. I just started here and ended here. That's a change in the position right here. But if I want total distance from 2 to 10, what am I doing? I'm integrating what? The absolute value of velocity. Now, why don't I need to know? Why don't I have to add that to where I began? Because it didn't ask where I was located, did it? This one wanted to know, where am I? Where is my position? Not the change in position. The change in position would be x10 minus x2. It just said, where am I? Like, I started here, I changed this much, I ended here. This one just says, what's my total distance? Right? Like if you guys told me, I ran 10 miles today, I'm like, oh my gosh, I know exactly where you are. No, I don't. I just know how far you went. Right? Absolute value of v makes all of those negative velocities positive, so that when you calculate the area and the velocity, it's all positive velocities. That's what that's doing. Total change in your movement or your just total distance traveled. Last one. If P is the rate of growth of a rabbit population measured in rabbits per year, and there were 100 rabbits in the year 2005, which we're going to call T equals 0. Okay? So we're going to make that our baseline, 2005. Write an integral expression that represents the rabbit population in 2007. Now, we'll assume, for lack of any other information, that if that's 2005, this is 2007, we'll assume that it was an exacting 2-year period. They should be a little bit better about that, like say in the beginning of 2005, at the beginning of 2007, or something like that. So right here, if I want the actual population, what do I need to know? What my population is at the beginning. What is my population at the beginning? 100. Isn't that like me saying, if P is the rate, by the way, if P is the rate, then what am I going to use for my amount function? Maybe big P. But you'd have to say, okay, I'm just going to let big P, I did that with F, right? Integrate an F and I get a big F. So if right here, I could call that big P is the amount. Now you'll see that you don't need it till you answer this, watch. But bottom line, I'm saying, okay, I want to know what is my amount in year 2. Well, the amount in year 2, which is kind of like this is T equals 2, right? 2 years later, is the amount in year 0, which happens to be 100, plus what? How much the population changed. Well, if I integrate a rate of population, little p, from 0 to 2, I get the change in the population, add it to the initial population, and I get the final population. But look, I didn't really need big P, did I? Because all I want for my answer is that. That's the expression. They didn't say an equation. An equation, I would need that. Expressions are not equations. So really, all I needed was this. Starting with 100, that's my initial amount. add the change in the amount, which is integrating the rate. And I know if I had given you this problem 2 months ago and said, hey, read this, and I had not said this, and I said rate of growth of a rabbit population, you would have probably said, oh, that's dp/dt, right? Because it's a rate. I get that. But they didn't say it was dp/dt. They said, we're calling it p. And you're like, okay, that's annoying. P prime would have made more sense, but they're calling the rate p. You've got to get used to that kind of stuff happening. Y'all with me? And here's even more annoying. Sometimes, I mean, really annoying, and this is where I just want to punch somebody at AP in the face, but I'm not a violent guy, so what? But point is, sometimes they'll go, hey, let P be the rate of the growth of the population of rabbits, and then let G prime be the rate of the growth of population of giraffes. And I'm like, why would you do that? Why would you let P stand for a rate on this part, and then G prime stand for a rate on this part? Why wouldn't you be consistent? Because they're evil sometimes. And they're going to try to mess with you and make sure that you're reading and thinking and processing and really have a firm grasp. And again, the upside is you can make like a 64% right and make a 5. And you can get 50% right, make 4. So you have a lot of built-in errors for yourself. But anyway. So anyway, that's what we're talking about here. That's the first thing I wanted to look at. And then I want to jump to this. So this is probably going to bother some people. I get it. Once you get it, I think you'll be fine. But anyway, let me just walk you through average value. All right, so here we go. Average value. And by the way, do you remember the mean value theorem, or at least the name of it from back in the day? And the mean value theorem said, anybody remember? So if you have a continuous function, the slope between the endpoints, which is just y minus y over x minus x, is going to be equal to what? The instantaneous slope, the derivative of the function where? Anywhere, at least, well, not anywhere, but at least some point, at least once. So the mean value theorem for functions said, yeah, if you got basically a function like this right here, that's the slope from beginning to end. Well, somewhere on this graph, at some particular, we called it a C value, at some place, the slope here will match the slope there. And we wrote it like this: f prime of x, whatever the derivative of the function is the same thing as y of b minus y of a over b minus a. So the slope from a to b, call that a and b. The slope from a to b matches the instantaneous slope, the derivative of the function somewhere on the graph. That's the mean value theorem. But there's also a mean value theorem for integrals. It's the same thing. You will see in a moment. Okay? But there are different times. Sometimes I know a function and can take a derivative of it. Sometimes I only have a derivative. So it allows you another way to think. But let me just walk you through where this formula we're going to use comes from. So right here, doesn't it make sense to you that the area below this curve can be represented by the integral from 0 to 2 of f of x dx? So that part should make sense. Now, does it also make sense that there happens to be, okay, before I say this next statement, does it also make sense that if I take the base from beginning to end and multiply it by the smallest height, that I get a rectangle whose area is clearly too small? And what I'm saying is too small is clearly is smaller than the real area. And does it make sense that if I take that same base and multiply it by the highest y value, that I get an area that's clearly too big? So if there is some x value, like right here, that gave me a height with the too small area, and there's some x value that gave me a height that's too big an area, then could there be, or should there be, an x value somewhere, we call it C, whose height would give me an area that's exactly the same as the real area? Because if one of them's too small and one of them's too big, it makes sense that there is a correct area of a rectangle somewhere in between those. All right? So with that in mind, could I call that height f of c and that base b minus a in this case? All right, so let's think about this. If the real area of this function from a to b found by the integral is equal to the base b minus a times some special y value. Now, there's only maybe one or two y values that actually work, but you'd have to find that x value first. But does it make sense that that special base times height that somewhere would be equal to the area? Well, look what happens right here if I divide by b minus a. That tells me right here that f of c, there is some value where if I integrate it and divide by that, that value matches. That is essentially my mean value theorem. Now, watch it look like the mean value theorem right here. Look what happens if I ddx both sides. If I ddx right here, if I ddx the left and I ddx the right, doesn't the ddx of f of c give me f prime of c? Right? When I ddx the integral, doesn't it cancel? And I plug the b in. And because there's also pretend like it's a variable with me. And I could also plug the a in. What do I see? The original mean value theorem. This is the mean value theorem for integrals. It's kind of the same thing, but you will see in a moment the application that you might use it in. All right? But we use this for average value, okay? So this mean value theorem for integrals is what we do when we want to find the average value of a function. Because take a look back at this f of c. This f of c just so happens to be the average of all of the y values. That f of c is that special value. It's the average of these infinite number of y values. Well, you're going to get asked all the time, what's the average value of blah? What's the average value of blah? And when you get asked the average value of blah, that's where the mean value theorem of integral comes into play. And that's all you're going to have to do. Problem is, sometimes I say, what's the average velocity? But I don't give you velocity. Sometimes I say, what's the average position? But I don't give you position. If I say, what's the average value of f? And I give you f, bam. But if I say, what's the value of f? And I give you big F, can't use this. But guess what's equal to big F? That when I simplify it. You will get more and more practice with this to make it make sense. But please, when I show you these things, don't miss them because they end up being some of the easiest problems on the planet. Now, I've given you a bunch of these little proofs, but let me walk you through them. Look down here at average velocity, and then we'll come back up and look at this. If I say, what is the average velocity on a certain interval? Bam, there's your formula. If I have velocity, I can integrate velocity from a to b over b minus a, and I will get my average velocity. You might even use your calculator. But what if I don't give you velocity? What if I give you the position function and say, what's the average velocity? Wait, what happens when you integrate v? You get the change in x. What represents change in x? Final x minus initial x. These mean the same thing, don't they? Now, if you're in physics and somebody asks you what's average velocity, don't you go initial position minus ending position? But if you didn't have the position function and you had the velocity function, you could go straight to this right here. But on the flip side, if you did just have the x function, you could use it, bam, right there, or you could take the derivative of it and use it right here. You have two options. But the bottom line is don't confuse. I have people all the time that I give them the position function and I say, what's average velocity? And they integrate the position function. No. Average anything. Guys, average of any function I give you. Any function. Integrate that function over the beginning and end interval divided by the end minus beginning interval. If I don't have v, then go ahead and integrate v, and maybe you have x to use. But they mean the same thing based on what you learned about the fundamental theorem and what you know about velocity and position. Same thing with average acceleration. What is my average acceleration? Right? If I have the acceleration function, bam. Right? If I have the a function and I say, what's your average a? Integrate a from a to b, divided by b minus a. Done. You might have a calculator. Done. But what if you don't have the a function? What if you have the v function? Well, good gracious, what's the integral of a? Change in v. So replace the integral of a with the change in v and do that. You'll see they're all over the test. Every year I'm like, why is this hard? You'll see it more and more and more and more. And hopefully by May 6th or 9th or whenever we take our test, you'll go, oh yeah, I got this. And you'll just steal points. So many ways to steal points. I mean, so many. But when you don't see those, gosh, then you got to earn them the hard way, which is okay. We're going to do that too. But man, steal the ones you can steal. Okay, so going to, but bottom line again, average value of any function is the integral of that function. Okay, if they don't give you that function, then you can't use the integral formula. But what if they gave you the big F version of it, right? That's a rate. They gave you the amount version. Well, you could use that without the integral. Same thing here. F of x equals the integral of f prime. What if I said, what's the average value? But I gave you the derivative function. Well, right here, the integral of the derivative is what? Change in f, right? Are you seeing this? Oh, wait a minute. That is not right. Why do I have that there? Good night. Maybe that's my problem. Right here. Average value of f needs f. Average value of f prime needs f prime. Put a prime in there. Good gracious. Maybe that's why people are struggling. I hope not. You have f prime on yours?
Oh, wait, no.
On that second one?
In the second one.
In the second one, if this is an f prime and I want average value, you got to integrate an f prime. But what's the integral of an f prime? You're back to regular little f. What's the integral of little f? You're to big F. Gosh, good. Put that in there right there. How did I miss that?
And on the bottom one.
And yes, and on this one right here. Now, the only reason I'm swinging that B minus A on the bottom out to the front, the only reason I'm doing that, and by the way, it wouldn't look like 1 over B minus A. It's going to look like 1/7. They're going to subtract the B and the A, and they're going to get a number. AP does that a lot. They put 1/7 or 1/10 out front. I think it looks better with the B minus A on the bottom. That's me. But sometimes they pull it up to the front because it's a constant. All right? But anyway, when you see average value, please do that. So let me give you a couple of examples. How much time do I have? Okay, so let me just give you a couple of examples. So here we go. Okay, so f of x equals, we'll make it easy, 3x squared plus 2x. All right. I want the average value of f from on the interval from 1 to 4. What is the average value of f? So what is my average value of f? I'm going to call it f of c. What is that? Well, what's my formula tell me to do? Integral. If I want the average value of f, I integrate f from 1 to 4 over a 4 minus 1, which is 3. So all I have to do is to integrate that, which would be 3x cubed over 3, which is x cubed, plus 2x squared over 2, which is x squared, I'm going to integrate that from 1 to 3, sorry, from 1 to 4, and then divide it by 4 minus 1. That's it. So all I would have to do is plug the 4 in, 64 plus 16, plug the 1 in, 1 plus 1 is 2, and subtract and divide by 3. So what, 80 minus 2 is 78 thirds, which is 26. So the average value on that interval between 1 and 4 would be 26. Are y'all seeing that? Now, what would you do if I said, what's the average value of 3 minutes? All right, so what if I said this? All right, my velocity is 3t squared minus 2t. Be careful. What is the average acceleration on the interval 1 to 3? Wait. Average acceleration is the integral of what? Acceleration from 1 to 3. I don't know acceleration. But guess what? What happens when I integrate acceleration? I get the what? The change in the velocity from 1 to 3. So what do I end up being able to use? The velocity function. So it turns out I didn't even have to integrate, did I? Because I had what the integral of A was. So you're going to be given either the function that you're taking the average value of or the function you get when you integrate. You just have to decide when to use it. Physics people know right now, oh, average value of accelerations change velocity over change in time. They know that. But mathematically, there's a reason. Because the average value, the mean value of integration, says that you can find it that way. That's why. So you're just going to plug a 3 in and go 27 minus 6 is 21. Plug a 1 in there. 3 minus 2 is 1. Subtract and get 10. Y'all seeing that? To me, that's one of the easiest things on an AP test, if you know the formula. Shockingly butchered. Hopefully not by you guys.
Yes, sir. What would you do if somebody walked in and called?
I would just freak out. I don't know. What do you mean?
I don't know, we were talking about.
It's probably not appropriate until you graduate to do that. For whatever social reason that's the case. I personally don't. I always thought it was weird being called Mr. Hurry. I've gotten used to it over the years having kids and teaching, but you can, hey, listen, you can call me whatever you want, but I can tell you this, it will be painfully hard when you run into me after graduation for you to call me Tim.
Yeah.
Like I've had people, like Coach Donaldson, he might, Coach, Health might, but it's weird for them. Like they go, hey man, I don't know. I don't even know. I honestly don't have a memory of it. Most of them just go poke their head in the ground. Hey, what's up, dude? And when I run into people that have 4 kids, hey, I want you to meet Mr. Hurry. I'm like, you're 45 now. And they're still calling me Mr. But I don't care. Once you graduate.
I always find it weird.
Yeah, I know. Yeah. Yeah.
Yes, yeah. Yes.
You know,
It's good to see.
That's 10th period, that's 11th period. That's back in the days of good sized classes. 9, 12. You what? Did you finish with that?
No, I didn't. I can't.
Oh, there.
I can't stay because I have to go to the train for. On Friday. Yeah, I haven't. It's like, it's like.
Looks like we're just going through. I think this is the last thing we learned new.
Okay, then.
Today.
I'll make sure.
So the next 3 days of class, Thursday, Friday, Monday, we are just, we're just doing more practice, looking at AP problems and how they show up, that kind of stuff.
We have like